There we go. Now you should be able to hear me. All right. So, yeah, good evening, everyone. Welcome to Kopernik Observatory's live stream coverage of the supernova in the Pinwheel Galaxy. We're a little bit late to the game with this supernova, but I think there's still a lot we can talk about and share and discuss, because maybe you've read a lot on it as well. So, yeah, it's been a while since we've started, since we've done a observing live stream. And I think our last one may have been the Mars and Comet back in sometime in the winter, February, something like that. So, yeah, so we're happy to be back. You should be seeing more of these observing live streams. Granted, there aren't any super major events happening in the next couple months, but we're going to focus more on some things you haven't seen in a while here on the Kopernik YouTube channel. So that could be observing some of the planets that are out, including Mars and Venus, of course observing the Moon, and yeah, it's a lot of deep sky objects. It's been some time since we've done a deep sky object stream, and thankfully this is one of them. We are going to be fighting the Moon a bit tonight with this one. It is a fairly well-illuminated waxing gibbous. We're pretty close to the full moon now, which will happen in the next couple of days. So there'll be some moon glow to work against, but I think with this object being near zenith in the sky, we should have a good chance of capturing it. So that's tonight's focus. If as time allows, though, we can jump around to some other objects that are out there. If you want to see the moon, we could do that. So we'll play it by ear and see what we'd like to do. For those that aren't aware of or if this is your first time here on the Kopernik YouTube channel, welcome. We've been doing this for a couple of years now, covering a variety of major astronomical events, and we've improved our setup as time goes on, and you will continue to see improvements over the next month or two as we further refine our setup and get ready to push out more observing content over the summer and into the fall. So, looking ahead to some of the events I do have planned, we're definitely going to cover the Perseid meteor shower. It's going to be a good year for the Perseids, so as usual, you'll see a stream from us on that. And hopefully you get the chance to observe the Perseids as well. Also in the fall, we have a annular solar eclipse coming up. Not in our area, it won't be an annular. We'll just get a little bit of the moon covering the sun, not too much. But we are working towards a way to hopefully stream out more of that annular eclipse, because we have someone that is going down to Texas where it will have more coverage. So we should look forward to that event coming up too, and then of course the big one in 2024 with the total solar eclipse in April of next year. So lots to look forward to on that front for big events, and we'll also just be doing our general observing streams along the way. So, yeah, let's talk about the equipment for tonight a little bit. As you can see behind me, and as you can read from the title, we are in the 6-inch dome, the Sarton Dome we call it, named after J. Sarton, one of the prior directors of Kopernik Observatory. And you'll notice, though, if you've visited our channel before and watched our streams, and when we've shown you video of the telescope, this is going to look different. And yeah, there's a good reason and story behind that. So you may notice it's much shorter. And that's because it's not the original scope that was in here. We have temporarily switched this one out with a same diameter scope. It's still 6-inch. It's still a 6-inch lens, but it's a shorter tube, which may benefit us tonight because a shorter tube means faster light capture. I can't remember exactly what this f-stop is on this one. But the previous one, the aperture, it was a f12, and this is a much shorter tube. So that has its benefits as well for image capture, which yeah, for deep sky objects that will come in handy. The reason why we have a smaller length 6-inch scope in here is because the other one is its lens is out for maintenance. And that's an important process that plays out with these scopes. You know, we got to keep them clean, got to make sure their lenses are working to their full ability, which that one was not. It was suffering from some astigmatism. So now, oh, and Joe comes in with that it's an f8. So f12 to f8. And by the way, Joe Bergeron is one of our Kopernik Astronomical Society members here at Kopernik, which is kind of like an astronomy club, and also one of our moderators tonight. So, yeah, let's see here. I am monitoring the chat as best I can. Let me call out some people that are asking questions or saying hello. Oh, some people saying, yep, there's been some brilliant pictures on the web. In fact, I think another member of our KAS, George Normandin, posted a picture from our 20-inch reflector on, at least on his Facebook page. I'm not sure if it's made it to the KAS page yet. So yeah, some brilliant images that you've seen. So let's see. Oh, Lorna is actually is asking a question. I'm glad you asked that. Wondering what happened to the astrophysics scope. And yeah, like I was mentioning, it is out for maintenance. The tube, in fact, is still here, but the lens is out to fix that astigmatism issue. So yeah, we really wanted to prioritize getting that back and getting it in tip-top shape. So stay tuned for more on that scope. You'll see it again, and I think it will look better than ever. But for now, we're going to use this temporary scope for our view this evening, which is a little bit faster, as I mentioned. All right. So yeah, why don't we, at least while we're waiting for the skies to darken a bit more, it's getting there. Let's turn the white lights off for just a moment. Some moon glow for sure. And there might be a little bit of twilight left out in the western sky. But like I said, this object is at zenith, so my hope is that we can get through some of that moon glow with a long exposure and at least capture the nova. Let's see, is there branding on this scope? There is, but I think it is a mead. This is actually temporarily loaned to us. Yes, it is a mead. I can't quite read the text underneath it. It is covered by the tube. But it is a mead, though, and it is a 6-inch f8. All right. So why don't we jump into Stellarium here a moment and take a look where this is. Oops. So let's pause it, and we're going to bring it back to current time. So as a general view of the sky tonight, we do in the western sky have the two planets that are out right now, Venus and Mars. Now notice they are in the western sky. We will lose those. not too long from now, in about a month, it'll become more of a challenge to see them. So July is going to be pretty devoid of planets unless you're willing to stay up late into the early morning, at which point you'll start to see Saturn and then Jupiter. But as far as convenient times, evening hours, so you don't have to stay up late, we're going to have a little bit of a gap on the planets. So we'll try and capture Venus and Mars on a stream coming up this month, just just before we lose them. And as you can see, yep, nothing else on the planetary front except the moon, of course. Then we will have the Milky Way coming up earlier and earlier as we head into the summer, the core of the galaxy. And yeah, that will be a nice view and a nice opportunity to do a live Milky Way stream, like we did last year. So we'll focus on the Milky Way too. But our focus tonight, like I said, is going to be near zenith, almost looking straight up into the sky. So we're focused on the Big Dipper here, the tail of the Big Dipper. And let me make sure that you are seeing that view as I am. I just want to make sure it's framed how I want it. Yep, oh, that's perfect. All right, so it's nice and centered for you. Okay, so we come down here. There's a couple of galaxies around the tail of the Milky Way. We want to make sure that we choose the right one. Let's go over here so we can pan a little easier. So as we zoom in Stellarium, you'll start to see these fuzzy objects pop out. So over here, oops, I can target it a little bit higher. You know what, let's just zoom in more. There we go. All right, so that there, so you look at this curve of the tail of the Dipper, or the handle of the Dipper, tail of the bear. Along that curve, you're looking down here to the Whirlpool Galaxy. So that's one galaxy that you can observe near the Big Dipper. Not our focus for tonight. Maybe worth checking out another time. But I'll zoom in here to show you the Whirlpool Galaxy. Okay, so that's a nice object to image. It's one of my favorite galaxies, I think, just because it's truly a galactic collision in action. You can see this smaller galaxy here being absorbed, sharing material between the larger whirlpool. And its name is very appropriate. Meanwhile, if we look on the opposite side of the handle, we'll find another fuzzy object there. And this will be our focus for tonight. It doesn't want to pinpoint the galaxy, so we'll zoom in a bit more and try and capture it. Come on. There we go. So this is the galaxy in question for this evening, and it's the image that you saw in the thumbnail of this video. That image, if I recall, was taken a couple years ago at Cherry Springs. When I was, that was my first time visiting, and the first day I did do some visual, and of course some of the other KAS members, the club members that were with me that day, they had visual scopes that I got to enjoy. So my rig, I decided to just really practice astrophotography. I know, granted, you're not really supposed to. When you go to Cherry Springs, it's such a nice sky. You're not necessarily, you don't necessarily want to be practicing. But then again, I'm still fairly new to that deep sky capture, so I had a lot of fun just bouncing around between the different objects and just seeing what kind of data I could collect. And it was such a nice pristine sky that my camera and telescope were perfect for what I wanted to do that night. So that image came from Cherry Springs on a moonless night. Very nice dark sky conditions. And the only, I guess, the differences that we'll be working with here, of course, the moon glow. The moon's out, so we'll have to fight through some of that glow in the sky. And the aperture of the scope is a little bit different too, as well as its um, focal length, focal ratio. So my scope is an f5, so it is a faster scope, and it's an 8-inch, so a larger aperture as well. But I think, especially since I wanted to use one of the dome scopes tonight, I think we'll do okay. At least finding some detail in the pinwheel and enough that we can pinpoint where the supernova is in the image. But yeah, I really like the Pinwheel Galaxy too. It is an accurate name for it, as you'd expect. You can see it's almost, granted these are static objects, they're not going to move on you. They're huge structures in the sky and they're very far away, so they're, by all intents and purposes, very static. But just looking at it, it's almost like your mind starts swirling it around, spinning this galaxy around as it flings these stars off at high speeds. You can see how the arms spread out and how the material spreads in this one. It's a nice face-on galaxy, much like the whirlpool, so it's nice that these are right in the same spot, or close in the same spot in the sky, so you can bounce between the two. Yeah, so the supernova, if I recall, is going to be in this arm here. So that's what we're on the hunt for, and it's going to be a magnitude 11 from what I've seen. That's about where it's been sticking for the moment, and it should still be visible for at least the next couple of months. So there will be more opportunities to see it if you have the right equipment at home. To just a scope, fairly large aperture scopes that you can at least find some of that detail in the pinwheel and enough so that you can pinpoint if you are in fact seeing the supernova. So, and we'll compare this to the stars surrounding it as well. The stars that are in our galaxy. All right, so that's where we're hunting for tonight. It's not too bad to find. This is a manual scope, meaning that I have to move it to the object I want to see. It doesn't do it for me. It's not a go-to telescope. So thankfully I have the nice bright Big Dipper to help me target it. And both of those galaxies, because they're so close to the tail, you can make some triangles. What's nice about the pinwheel is that this is nearly equilateral. So here's the pinwheel again. And if we take Mizar and we take Alkaid, we can draw almost an equilateral triangle to find it. So using a bit of geometry to target these objects in the sky. And similar method can be used for whirlpool as well. Not quite an equilateral triangle, but you can form more of an isosceles there to pinpoint where whirlpool is. Okay, so let's see if we can find it. This is why I have that, and for now I'll just zoom in on pinwheel. That's our target. So yeah, that's why I have the two camera view. So I have my presenter camera that I'm talking to you on now, and we also have the telescope camera, so you can see me add equipment to the scope and get it on target so that we can capture some data. So it's been a while since we've done a stream like this where you get to see the setup, and I did that intentionally because I've been waiting for the skies to darken a bit, and we got a lot of the discussion out of the way, but there's more to come on that front too. And just so you know, my plan for this stream tonight is to maybe wrap up around 11. Hopefully that means an hour of data capture on Pinwheel. And like I said, if there's enough interest, we could bounce to the moon after getting some images on the supernova, some eyes on it. So some options for tonight, but it will be a shorter stream. I will be opening up the line to questions too. So as we discuss the supernova, again, if I haven't mentioned it by name, this one is called Supernova 2023 IXF. So there's some story to tell there with how it was discovered, and some things we can certainly discuss as we go on tonight. So why don't we get started by at least targeting the scope, and then I'll get my camera mounted to it, and we'll see if we can get eyes on the Pinwheel Galaxy and its recently discovered supernova. Alright, let's see, actually, let me get my streaming software on this screen so I can make sure that you can see what I'm doing as I set up. And in fact, why don't we, since those are tiny views, why don't we switch to this big view so you can see me set up as we go. Make sure my mic is working. It is. Okay. Oh, there is the Dipper. Yeah, that's pretty high up there, as Stellarium showed. I think this object is something like 78 degrees in altitude. It's not quite zenith, but close enough to make it a neck breaker object. Granted, you can't see it with your eye anyways, but the Big Dipper is way up there. Now that is optimal, if I haven't mentioned already, because you're looking through less of the atmosphere. Less atmosphere you look through, better chance you have at getting some decent data. Whereas, looking at the horizon, if there's an object, a galaxy, a nebula, some diffuse object like that, a dim object, you're looking through more of the atmosphere. You're not going to get as nice data as at zenith. I can go for planets too. Oh, other way. All right, we're making that equilateral triangle with Alkaid and Mizar. Alkaid. I'm actually, let me get my camera up here, and then I'll lower this panel. And that way I won't have to go down the steps again. Just hang out right here. So at this point, let's see how this looks with the red lights on, because I'm definitely going to need to minimize the white light in the room wherever possible to try and target this visually. How does that look? Turn this up a little bit. Can you still see? It could be better. Well, we can leave them on for the moment. Until I get a little closer. Alright. Get this out of the way. Here. Tight. And I would be interested to hear from you, because we've tried a couple of different stream formats for the observing live streams. Sometimes, especially in the winter, I'm inside. Other times, in the summertime, I've been out in the domes. I'd be interested to hear what you prefer. Do you like seeing the setup? The setup process? You go and find it? Or would you prefer something that feels maybe more produced, more structured inside? I think I have a personal preference between the two. Maybe it depends seasonally as well, what I like to do. But I do want to hear from you because I'm happy to do either one. Let's see, how's your view of that? Oh, that's pretty good. It's working out all right. In the winter time, it does become more of a challenge to be out in the domes, but it's not like we can't set up a remote camera out here for when we are making adjustments to the scopes. I think it might be just as interesting to see the objects, or it might be just as interesting to see the setup as it is the objects, is what I want to say. All right, we need to make an adjustment to the dome. Do you have eyes on the dome? Yes, you do. You can see the window, so we're going to rotate the dome a bit. Gives us a little bit more. Okay, how are we doing? So even in the white light, I can still reasonably see the handle of the Big Dipper. Now, we'll take the lens caps off. By the way, I'll just show you on this camera, don't observe the sun without taking off or without making sure, rather, that the front lens cap is on there, or ultimately, don't forget to put the front lens cap on the finder scope. This one here. I just took these off. This one's the bottom, this one's the top. Because we often do use this to observe the sun, and this was left off for a solar observing session. So as soon as the scope got on target, there's really no reason to use this one at all, so it should be covered up in the end. As soon as it got on target, all of that sunlight came through here and it melted the bottom cap of the finder scope. So it gives you an idea of just how powerful that sunlight is when captured in a lens. I mean, you think back to a magnifying glass, right? You can capture a lot of solar energy and focus it down and cause some problems. So tonight we do need it, but I'm going to remember here. We'll put the top cap on that finder scope up here, so we can block any sunlight that comes through the next time we do a solar observing session. So we're going to do a nice wide field eyepiece. That's going to give us the best chance to capture a good amount of light. It gives me some, you always do this when you're trying to find an object. That way you can see reference objects. It'll help you pinpoint this very dim Pinwheel Galaxy. So this is a 40 millimeter I'm putting on. Here, I'll show you. Swing it up a bit. There you go. So this is the 40 millimeter we just attached to the right angle on the scope. That right angle has a 45-degree mirror that's going to bounce light at, as you'd expect, a right angle. So the light comes through the tube, bounces off that mirror down here. That mirror has no other optical purpose than to just redirect the light to a more comfortable angle. All right, now here is where, even though I can see the stars that I want, I think I'll still have to turn down the white lights, and I will also need a shorter ladder. I'll just use the step stool here. Just so I can get up to that finder scope. It's just high enough that it's out of my reach. Oh, someone says, Lorna says that they like seeing the setup. All right, that's good. It's just a good data point for me, just to understand what you enjoy on the channel. So I am going to turn this down for a moment. Maybe, yeah, I guess this is the best thing we can do. So it's going to be a little bit dark, but I will still explain what we're doing. I won't have much luck spotting this in the bright room. All right, there we go. So remember, I showed you earlier, we kind of make an equilateral triangle with Al-Qaid and Mizar. Al-Qaid is the star at the very end of the Big Dipper's handle, and then Mizar is the next one up along the handle. Let's just see what we have in the scope here. It's pretty well focused. That's good. Let's see, might make a minor adjustment to that. Yeah, get a little bit sharper there. That we can, if we do see some structure, we'll have a better chance at that. So right now I'm going to look in the finder scope, and in fact I'm going to turn down the red lights even a bit more. They are shining in my eyes a tad. Still looking in a bit of darkness there for you, but we'll get there. Bear with me. You'll just hear my ghostly voice in the dome. We're pretty close here. Okay. Now with objects like these, when you're viewing them visually, you're definitely going to want to use your peripheral vision. Look off to the off center once you get it inside the scope, and that's going to reveal more light from the object. You're not using your direct vision, so crisp detail is not going to be a really option. Not going to be an option there. I mean, think about how just looking at the screen right now, anything in your periphery is going to be blurry. It's not in crisp detail. But you are going to make out more light from the object. And then if you really want to collect a lot of detail, that's where the camera comes in, which is what we'll be using tonight. What is our tracking on here? Okay, stars. This scope, if you've been in this dome before with us virtually or in person even, this scope is on a tracking mount So there we go. We were a little bit low, I think. How's this? So once I get the object in, it should stay on top of it for quite a while. We can make adjustments live as needed, which is a nice benefit of being in the dome. I'll set my glasses down a moment here. I don't really need them. And I'll probably drop them if I don't. Alright, there is a ghostly object right about there in the finder, if I'm seeing it correctly. So let's see how we're doing with that. In the main objective. Oh, a plane just flew into the eyepiece. Well, not into it, but you know what I mean. That was fun. Actually, take a quick look here. Probably has moved on already. Wish I was wearing my glasses because I do struggle a bit. Oh yeah, okay. There it is. Yeah, that was kind of tracing back its trajectory. It is about where we want to be. And if you're not quite sure if you're seeing the ghostly object in the main objective, you can give the eyepiece a little shake. Just add a little bit of vibration and see if whatever object you're seeing, if it's truly there or not. It will move relative to the stars. It will keep up with all the rest of the star field. That's what you'd like to see. Oh, challenge at zenith for sure. But this is part of the fun, I think. You know what we're going to do? We're going to trace back rather than trying to just target it with that equilateral. For now, let's get to Mizar. Mizar is very distinguishable because we'll have a bright star and a dimmer star right next to each other. And frankly, I gotta bring it down. Come on. Gotta get you a bit lower, Scope. There we go. A little bit lower to find Mizar. Okay, there it is in the field of view. Yeah. It's looking pretty crisp there. So can we find it in here? Just about maybe. There's a satellite flying in front of the lens. That's fun. So many of those out there now. Oh yeah, remember when I told you about the neck breaker object? Yeah, this is definitely one of them. Move it down just a touch. Okay, there's Mizar in the main objective. Alright. That's good. That means we are pretty well centered. Yeah, I'm not unhappy with that. Bring this down just a touch more. There we go. I can move this out a bit. Alright, that's centered, so now finder scope should be in good shape. Oh yeah, that's good. Okay. Now we need to go move a little bit in right ascension here. It's nearly there. I need to move the dome again. I'm losing the view of Mizar in yeah, just a little. How are we doing in here? And ghosts. That's what we're looking for. Ooh, it's actually pretty warm. What is the temperature? 72. Must be relatively humid. $72 feels not wouldn't feel too bad, but yeah, it must be a little on the humid side. Well, you know what? Here's what we'll do. We're going to bump the rate up, and we're going to just do some tracking around. Yeah, I know it really isn't high enough speed for that. Oh yeah, this is a painful one. Right nearby. And my next option is to start just to hook up my camera and just start taking some exposures and bouncing around from there. Because, yeah, I guess given with the moonlight the other day, it was pretty challenging and to spot it, the pinwheel visually. There was something there, for sure. You could see the presence of this ghastly object. Let's get the camera hooked up, so at least you can see what I'm seeing. We'll turn the white lights on for now, so I can see my camera hook up. Hello again. Let's bounce to this view here. There we go. So the camera of choice tonight will be a Sony a7 III. I say camera of choice, that's almost always the choice. Here you go. This is just the mirrorless wide angle, well, full frame camera that we're going to be viewing. And let me just switch out the lens for my adapter quick. We don't, when we're achieving prime focus through a telescope, the scope is the lens at that point. Really would be nonsensical to put a lens between a lens and the camera. So we're going to hook up the adapter. And now it's just going to be the sensor hooked up to the telescope. So this is what the, well, let me show it on this camera. It'll be a little bit more clear. This is the camera, and this is its 2-inch adapter, and there you can see the sensor, the full frame sensor. All right. Let's see. We're going to just take the whole right angle assembly off. Just go for this balanced enough. Let's come over here and grab it in, and then we can switch out the right angle assembly for the camera as needed. But for now, we're just going to pop. Oh, you can't see that. Let's move it out this way, because I'll be able to get it back to where it was in just a moment. Okay, that is secure. Tension screws are in. At this point, I'm going to take off the neck strap because that becomes a liability when you move the telescope around. At this point, you don't need it. No sense in having this extra hazard. Handy for setup, but as soon as you get the camera mounted, I would take it off. And definitely take it off around your neck before you attach it to the scope. Alright. Drop that out. We need this one here. Yeah, that should work. Pretty easy setup. Wire this up here. Wire this up here. Now here is where it's helpful to cord manage a bit, cable manage. You want to make sure there's enough slack, but you also want to make sure that if, in a worst case scenario, a cord got pulled, if that happens, you want to make sure it's not going to damage your port and it's not going to damage the telescope. So find a rigid structure somewhere, either on the tube assembly, on the pedestal, something that's not going to be ripped off and damaged is what you're looking for. Alright, we're going to move this back to roughly where it was. We're also going to move the computer out a bit so we have some more slack to work with. Okay, back to where we were. Let's see how that looks. Bring this back to manual mode. All right, and we are going to try to wipe lights off. Go. Now our goal is to see some stars. Next step. This one might need to go all the way out, actually. Is anything like this saw before? And yes, that is the case. All right, we have stars. Bring our ISO up. And now we gotta get you seeing what I'm seeing. So let's go back here, and we're gonna bring up this camera view for you. This away. All right, we've got stars in that view. That's working. Let's move this and jump in here. Video capture. There we go. Very nice. Okay, so here's what we're seeing right now, which is stars. Can promise you that. Now let's reduce the exposure and just take a quick snapshot here. Uh-oh, didn't like that. Well, we might have to go to the other capture method. Can try this one instead. This might actually work better because then I can remote capture on the computer over there. Let's unwind this. I think some people may have shown up here. I hear some voices in the ether. Alright, let's pop this out. Pop this in. And we'll try this again with a different view from the camera. We're going to toss this one, this weird green screen that we have going on here. Transition that back. And now we'll go in here. adjustment on my camera. No, we don't want that. Look for a moment. Okay, there we go. Try that. Alright, it's working on connecting. Let's see if we can get it officially connected. There it is, awesome. Yeah, this will be the better setup, I think. We're frozen? Uh-oh. Why are we frozen? Let's find out. My audio should still be coming through, but why would it freeze the webcams? Let's try and, let's see, is this one still going? That one's still going. My camera's not going. Integrated. Do a little dance. Alright, now I think we're back. And we'll bump up the exposure once again here so I can see if there's stars. Yes, there is. Lovely stars. Alright. Let's jump to here. We're going to capture a window now. And remote. And bring this down. Okay, yeah, that should work. Alright. Sorry about that. Now we're back. So, now this is the live view, the live capture from the scope, updated about every quarter second. So, it is technically a video. It's just a video playing at 4 frames per second. And now, see if we do a quick capture. We'll do that from the remote side. Oh, something just flew in front of the lens. Maybe a satellite. It looked like a streak for the reason I just said. It's a quarter second update. Okay, and then viewer. Let's see what we're seeing. What do we have to work with here? Okay, so far just stars. Let's crank up the exposure. That was a 5-second shot that I just took. Bump this up a bit. Again, we are seeing a live view through the scope. We are not quite centered in on Pinwheel just yet. Alright, we have... Oh, we're picking up a little fuzzy in this image. That's progress. It's not Pinwheel, but it is... Yeah, that's almost definitively a galaxy. Yeah, lots of little fun fuzzies there. Okay, let's even crank it up one more step. Do the ISO a little bit, and then crank this up to 25 seconds. This is also helping me gauge what our tracking is like. If our tracking isn't staying on top of the object too well, then we're going to be limited on what we can capture. And of course, what would you call it? It depends on how well your mount is tracking. So that depends on the balance of the scope. But I think this one was tracking pretty well for our Friday night programs when we were using it visually. And it looks like at 25 seconds, yeah, there's minimal streaking in the image from the stars, minimum star trails. Oh wait, is this Pinwheel over here? Ah, I think we have it. Oh, yep, that's definitely Pinwheel. It's in there. Who knew? Okay, so I just need to narrow down what we want to see here. And maybe what I'll do is in this window here, I'm going to change this to let's flip these windows around. So in the smaller window, I'm going to put the live view. In the bigger window, I'm going to put the frame captures. That makes sense? That way, I mean, because we're really not going to see any live imagery beyond maybe a point of light for the supernova. So, yeah, I think it's better that if we do it this way. We might see the point of light, but we won't see galaxy structure in the live video feed. We'll only see that in the frames, the exposures. So we'll put that in the big window. This is going to be live from the 6-inch telescope. Well, so for now we're going to mostly stick to my webcam view here on the laptop. Then finally we can open this up for some discussion. I'll keep that there, but we're going to move this here. Oh, what are we adjusting now? Okay, there's that, and then we just got to bring the viewer in. So that we can see the exposures that the camera takes. This is going to come down here. Just setting up the scene for you. This is suboptimal. but maybe we can do it like this, switching between the two. Or, actually, better yet, let's make this a square. And zoom out here. There you go. Okay, just about fitted right. Okay. Let's try that. That should look reasonable for you. So now, below me, let me turn the white lights on for a second. Below, we have the live view from the 6-inch telescope, so that is a 1/4 second video feed update. And in the big window, wrong way, in the big window to this side, we have the exposure capture. So you're going to, as I take images of these objects, you'll be able to see them, the frames updated there, frame by frame, as we change exposures, ISO levels, and everything. So let me turn the white lights off now. If we zoom in here on our frame, this was a 25-second exposure. Right over here, you see this little fuzz? Maybe you're just making out some wispy arms. Maybe. There's this long arm that I see on my screen that I can make out pretty well. That is what I believe is the supernova right here. It's a pretty bright star, though. We'll have to compare that with some exposures, and I'll take a look at some recent images and compare. But either way, that's the pinwheel, and now we just need to get the live view mapped onto it. So, let's see. Bright star there, 3 stars there. So we need to bring that upper right quadrant. And now I can just do some fine motions to target that. Yeah. That'll work. We're going to get this nice and centered. All right, let's take a new capture. Another 25 second. We'll get detail out of Pinwheel. And while that's taking, let's see. Actually, I'm going to look on my phone for the live chat. That'll be the best way to monitor that, I think. Okay, let's see what we got. All right, we just got the new frame in, I believe. Let's see. All right, we got a satellite trail on this one. But yeah, Pinwheel's down here now. I moved a little bit too far. So we got these 2 stars here, those 2 stars there. Gotta move that up now. getting there. Let's try that. Taking another exposure now. When I do take an exposure, as you might expect, the live video capture stops. So it freezes, and as soon as the exposure is done, that video feed below me will update again. Okay. There's our new one. Yeah, nearly there. All right. Let's see. If I recall, it's these. Just trying to use some stars to narrow down exactly how I want this to move. Yeah, that's the big one out there. Okay, so I want those ones. We just want to move it. Down a bit this way, down a bit this way, up a bit. Down a bit. Okay, try that one. Now I'm pretty happy with this, given the conditions we're working against tonight. I'm pretty happy that at 25 seconds we're getting some detail here. And at the very least we are capturing the supernova. Yeah, wow, I guess that really is going to be it. All right, what do we have now? Now our mission is to try and get some more detail, if we can, on the pinwheel. But if we zoom in here, this was a 25-second exposure at 3200 ISO. This here is the core of the Pinwheel Galaxy. And over here, this bright one is what I believe to be the supernova. And I think that Joe agrees with that. I'll have to see I'll have to look at the chat again, see if anyone else thinks that we're on the right track here. But because there is a dimmer structure below the supernova from images that I have seen, and that is right here. And then above that is going to be the supernova itself. So yeah, I think it's that one. So let's keep trying this here. Let's see what we can do. I think if I gotta turn silent shooting off on my camera in order to do bulb setting. Try that. Now I think I should have access to my bulb mode. No, that didn't work. Let's try again. Well, we can start with a 30-second. I'm pretty sure it was just silent shooting that I had to turn off to get my bulb mode on. If you're wondering what I mean by that, the bulb setting on a camera will allow you to take longer exposures beyond that 30 seconds. We'll bump up the ISO and bump up the shot to 30 seconds now. So we were at 25 before. I just want to make sure my framing is good. Oh yeah, it's pretty well centered in there. Yeah, I'm happy with that. Alright, bit of a waiting game with this, but this is what it takes to capture detailed deep sky images. Oh, there goes the shutter. What do we have? Oh yeah, that moon glow is starting to come out now. Oops. But we got some more light captured there, some more structure from the galaxy. So yeah, let's see. Yeah, this is pretty spot on with the frame that I'm using to analyze my image here. Yeah, so you have this long, if we zoom in, we have this long tail here, long arm of the Pinwheel Galaxy. Remember when we were looking at Stellarium, I can actually snap back to that. We were looking at Stellarium, we'll zoom in a bit. And we'll rotate this so that maybe. Well, it was going to let me rotate for a moment, now it's not. Come on. Yeah, there. I'm just trying to frame it up so we have a similar view to what we're seeing in the frame. Yeah, so those three come down. All right, we're almost there. Yeah, it's about as good as it's going to get there. Yeah, I'm happy with that. So that's almost lined up what you're seeing in Stellarium. Again, Stellarium, if you want to download it, stellarium.org. It's free software, and it's at your at-home planetarium. Wonderful tool to use at home. But that's the image that they have in Stellarium for Pinwheel Galaxy. And if we switch back to our camera view, the frame that we captured, it's aligned nearly the same way. So same orientation there. So when we look in Stellarium and we see this arm, this long arm stretching out and away from the core of the galaxy and extending even further with the diffuse material here, the supernova is going to be right in here. So that bright zone that you see there, and then the supernova, it's not in this image, but it will be just above that. Okay. Oops, bring the viewer back up, and then we'll jump back to the viewer mode. So yes, that bright one seems like it is the supernova. So there it is. Brighter than the core of the galaxy itself there. and even brighter than some of the surrounding stars. Let me bring the main camera view back up. Sorry about that. Oh no, it is on. Oh, were you not seeing? Because I'm in studio mode. You weren't seeing Stellarium. My fault. Let me show you this again. So this is our view from the camera. Okay. And then if I flicker Stellarium back on, I have it framed up with their image of the pinwheel. No supernova in this image. This is an older image. But I can give you an idea of where it is. Supernova should be right in here, just above this bright structure. Right in here. Okay. And if we go back to our view, we see on the camera, there was that bright nebulous structure in the galaxy, and now just above it we have this new star showing up in the supernova. Supernova 2023 IXF. So we do have eyes on it now. We can try and see if we can pull out some more detail on this. You can see with all the moon glow just how diffuse this object is looking against the brighter background of the sky. But again, we are at zenith, and to my eye, even though there certainly is moon glow tonight, it looks pretty dark up there. So let's see what we can do to bring the bulb mode on. In the end, taking a longer exposure might not be to our benefit, but I would like to still try. And then we can take some questions from the chat about the supernova. I think maybe continuous shooting is on, and that's why I can't access it. Let's see if that's the case. I did have that turned on for one of our programs up here. Drive mode, continuous shooting. There we go. Bulb. We got our bulb setting. All right, let's try this. Let's do a minute. We're going to take a minute-long exposure. We'll take a look at what our star trails look like, see if the tracking is good enough to support a 1 minute long exposure. We're keeping the ISO the same, which all the moon glow here might be a mistake. Might be better to tone that down, but we'll try this. We'll still be able to determine star trail quality and all of that. Camera's battery's doing good, so we're in good shape here. So this is going to be double the exposure time. So you see how bright that image is there. We'll see what we can get out of this. About 15 seconds left. 5, 4, 3, 2, shutter. Not too bad in terms of glow. Could be worse. And a little bit of trailing. So we pan around the image at the brighter objects. You can even see it with the supernova. There's trailing on the supernova too. And, you know, in the end, we're really not gaining much from this. Yeah, this looks like we've reached our limit. And with the trailing, I'm happier with the 30 second. Let's bring it back a touch. And we're also going to knock down the ISO to 4000 and see what that looks like. But as we continue taking some frames, let me jump into the chat here and see if I have any questions that can be answered. Whoops. Hang on, let me see my viewer. Okay, that isn't too bad. I like the color of the. It's not too bright. Granted, you could always knock that back in processing and pull what data you can from the Galaxy. Yeah, let's see. Where was Joe's question here? I had to double check myself to see if there was one hidden away somewhere. As far as I can tell, Joe, I do not have an auto stretch feature on this one. Let's just double check one more time. See if I can find it. Just after quickly looking, I didn't find one, but I think this is pretty bare bones, their utility. Sort. Let's see. Go over here. Still have Imaging Edge open. Come on. Because that's just viewer software. I don't think it has very much in the way of editing. This might be it. Shading. Oh, those are all total value. Oh, tone curve. Yeah, because I usually just bring my photos into my processing app on my Mac. So I do not have my editing software on here readily. Oh, this might be what. Oh, what's this? Oh, that's an uneditable histogram. That's not helpful. Well, anyways. something to look to add on this setup here. All right, I'm going to back up here because I think I missed some questions. So Chris was asking, where is the supernova? I'm not certain what context that was in. I saw one of our moderators, Astronomy Web, followed up there. But just so everyone knows, this is in the Whirlpool Galaxy M101. That's its catalog number, its Messier number, M101. And it's right within the Big Dipper, right within Ursa Major, along the tail. The tail of the Big Bear. Handle of the Big Dipper. Either one. All right, let's grab another 30-second exposure. That worked. Did it work? There we go. All right, what else do we have? So we have a question about resolution. And I can give you megapixel value and just see. This is on a Sony a7 III, so my full frame captures are 24 megapixels, which is something like 6,000 by 4,000 in pixel resolution. Yeah, 6,000 by 4,000. All right, great question. And Sean also asks, are you capturing with a normal camera and a specialty adapter, or are the actual image sensors proprietary to the scopes? This is a totally, I know someone followed up with you here, but this is a totally normal camera that you can just buy off the shelf. It's a Sony a7 III. It's a, more high-end. It's a full-frame system, so pricier. It's not a point-and-shoot, but it's a great camera, very versatile for both astrophotography and just day-to-day photography. I've enjoyed it a lot. There are a lot of good options out there, so I'm not like promoting Sony in any way here. That's just the one I ended up with. A lot of them will serve you similarly. And of course, if you want to focus directly on astrophotography, then there are a lot of options on that front. There are a lot of companies that handle that, like CWO, and you can get some pretty nice rigs set up with that are more related to astrophotography. In fact, that's really their sole purpose, is to hook up to the back of a scope. But this does have adapter. It has a T- adapter, so I can just slot it into the 2-inch section of the telescope where the eyepiece would go, so I can achieve prime focus. Yeah, we're certainly suffering from the moon tonight. Oops. Let's see here. We're looking for a pinwheel. You say that's NGC 5474. So that is, from our perspective here, it's to the right side view, I think. Right, there's that long tail, and then up here. Let's go back to this one. Oh, there it is. Yep. So yeah, there's Pinwheel. Make sure you're seeing this in your view. Joe brought this to our attention here. Make sure you can see my mouse. There we go. So here's Pinwheel. Maybe we can jump back to this dimmer photo. Yeah, it comes out better in this one, I suppose. Even better in this one, maybe. This one might be our best shot. This is Pinwheel. And then over here we have this NGC 5474. This is a dwarf galaxy. Closest galaxy to the Pinwheel itself, a companion galaxy. There's a little dwarf galaxy right over here, a little fuzz, and then a Pinwheel here. Okay. And what else did I miss here? Let's see, what were you saying? Yeah, we're switching between Stellarium, so I can turn off viewer and show you this. Yeah, there when we look at Stellarium, this one should be behind. Let's pop that window behind this one. There we go. Yeah, there's no. This is where the template starts to fall apart a little bit based on how I have these windows configured. But we'll go back to viewer. I think that's really our focus for right now, is taking a look at the supernova itself. Let's do another frame capture. I think this one was at a higher ISO, and I almost like it better. Let's jump up to 5,000. So we are heading towards 11:30 now. And yeah, my intent was for this not to be a super long stream. I just wanted to take the opportunity while this supernova was in everyone's minds, just to see if we could find it, get some images of it. And I'm quite pleased with, at least, you know, we set out what we meant to do, even in this moony, even in these moony conditions. So I'm happy with that. So again, there is the supernova there. From the numbers I was seeing, it was people were saying magnitude 11, which, yeah, once we get out to this apparent brightness, I start to lose my sense of things. So that could be right. But it is brighter than I was expecting. Now, of course, maybe you know supernovae. They throw off a lot of radiation, and they can be harmful for solar systems, planetary bodies, especially those with life on them, if they're close enough. Now, with this galaxy, it is far, far away. I believe 21 million light years. Yeah, about 21 million light years away. So it's easily a safe distance. Through measurements taken through the Chandra X-ray Observatory and data collected through there, they estimate that you'd probably have to have. Oh, I see what you mean. It's the. Let me make sure that you can see this view, or scoot this out of the way. So now you can see the live view again. So yeah, you'd have to be about 160 light years. That's how close a supernova would have to be to and go off and have a noticeable effect on life here on Earth. So we're reasonably safe from this, especially this supernova, but any other prospective supernovas too on the horizon, so to speak. So not a huge concern on that front at all. This is just something that we get to enjoy in a galaxy far, far away. Then, but of course, when this went off, if any planets around it had life on it, it may have had a bad day within that 160 light year range. So this is a Type 2 supernova. There are two primary types of supernova. Type 1 is going to be related to binary star collisions. So you have the sharing of material between a moderately massive star and a white dwarf. So as that material is shared and as the stars reach a certain mass, it'll end up going supernova in that cosmic explosion. And those can be pretty bright, and they can also brighten up quicker than a Type 2. And there's different levels of Type 1 as well. There's A, B, or C, and those depend on the spectra that you end up seeing, what kind of elements are actually inside those binary star systems when the supernova goes off. But this is a Type 2. Let's focus on that. This is was a massive star, and you're talking about something in total of 8 solar masses. So a much larger star than our own, and with these large stars, they start to burn heavier and heavier elements through that process of nuclear fusion. These atoms are slamming into each other more and more, building up heavier and heavier elements. And for the lighter elements on the periodic table, you'll have all of that is where energy is produced. When you have that process of fusion, hydrogen atoms slamming into each other to form helium, that produces energy. And so on and so forth, up until you reach iron. And after that point, it starts to become an energy absorbing process. So now it's flipped. Now when you start building out heavier elements after iron, you start using energy rather than creating energy. And that's where things start to fall apart. You have this big iron core that gets built up at the core of the star, keeps building up, getting more and more massive. And eventually, the process decays. So this big iron core, if you have something that's less than 3 solar masses, the iron core will I lost my train of fire. You end up having this disparity between these explosive forces of the star through the process of fusion and the gravitational forces from that iron core. And eventually the explosive forces can't counteract the force of gravity from that huge core that's building up. That can be 3 solar, we were talking 3 solar masses or even greater in some cases. And at that point, you start to have stellar material collapse in towards that iron core. And as it does, you get these shock waves as that material rebounds off the core. It's a very high energy process. Think about that, the forces of gravity involved here. And more than that, as this iron core builds up, you have atomic interactions going on that forces that material to become a neutron star. So you have that neutron star core being developed as you run through this interaction, this supernova interaction. And then finally, those outer layers get blown off as they rebound. That's where the actual explosive process happens, the very high energy, intense boom, cosmic boom. And then, as long as that core was, and that neutron star was 3 solar masses or less, that's where you just end up with that neutron star. Once you go beyond that, the core exceeds 3 solar masses, that's where gravitational forces become so strong that you will get a black hole out of this process. Some infalling material from the star will go into that black hole in that case, but not all of it. You'll also get that rebounding action, even if a black hole is created from... Because in that process of gaining more and more mass, that iron core getting bigger and bigger, you'll eventually get a temporary neutron star that will cause rebounding and that supernova. But eventually it will collapse in on itself and become a black hole. So that is an example of where we get our black holes from. So it's unclear at this moment. It is a type 2. We know this was from a supermassive star, not a type 1. Or at least at the very least, since it's so new, it's highly suspected that it's a type 2. And so now the question would be, what does it become? Is the mass of that core? Is it a neutron star? Is it a black hole? That's the question. And this process and study of this star will go on for a number of months to come. So yeah, this is the stellar life cycle in action. You can see instances of the stellar life cycle all throughout the sky. You can look up at our sun, middle-aged star. You can look at the Orion Nebula, a stellar nursery. You can look at planetary nebula, which are examples of towards the end of the stellar life cycle for a star our size. Or you can look at supermassive stars in their end. So Betelgeuse is an example of a supermassive star that can go supernova and will at one point in the future, but it hasn't. At least from our viewpoint here on Earth, we have not seen that yet. Maybe it has gone off, and we're just waiting for the light to get here. But this is a case that 21 million years ago, this supernova went off in the Pinwheel Galaxy, and now we finally get to see this light visit us in all of our telescopes, all of our wonderful camera gear, and we get to observe it together. So as long as you can see the Pinwheel Galaxy right now, you can spot the supernova. You can, as we mentioned, it's even brighter than the core here. All right, in our discussion there, let's see if we have any questions. I am thinking of winding down the stream here, so if you do have questions, feel free to submit them in the chat. As always, too, if you want to support Kopernik, let's see. Okay, no new chats yet. Although Joe, there's a good one. Joe says start at 7 o'clock from the nucleus is about magnitude 13. Oh, the star. I don't know why I said start. The star at 7 o'clock, so down here. Okay, so 13, 11. Oh, no, that makes sense. Yeah, so if this star here is a 13, the supernova is an 11. That's 2 steps up. That makes sense to me. Thank you for that perspective there. Where was I with this? Yeah, if you're in a position to support Kopernik, you have a couple ways to do that. Of course, you can like and subscribe to the channel and this video. We'd love to have you return on future observing streams. As I mentioned, this is us ramping back into our observing live streams, hopefully to produce some more consistent content for you, both on our Friday night live streams, which you will see tomorrow. We have one that will be, that you can stay tuned for. It'll premiere at 8:30, and it will be related to our event coming up on Saturday, which is called Rocket Fest, where we have a whole host of people come up and launch rockets they've been building at home. So tomorrow's presentation will be on rockets, our local rocketeer, Bradshaw, I think is their name, and they'll be giving us a tour of their collection, how they got into rocket building, and so forth. This is very fascinating. He has an extraordinary collection of rockets, so definitely worth coming to the stream and checking that out tomorrow. We'll continue to post our Friday night live streams, so look out throughout the summer for that variety of content. If you're interested in what's coming up in the night sky this summer, go ahead and take a look back at last week's Friday night live stream, which was on summer skies. We covered some of the events we'd like to shoot for the observing live stream, so our night sky lives. And Perseid meteor showers is probably the biggest one that will be this summer, but we do have some other objects that we can focus in on. Some deep sky objects we can try for maybe on a moonless night. By the way, Perseids will be moonless for the most part, at least in the evening into the early morning hours. Eventually a waning crescent moon rises up, but otherwise it will be a good year for the Perseid meteor shower. We have some solar eclipses on the horizon too, so we'll look forward for those big events. But I definitely want to push some more Night Sky Live content to you as time allows. I am a science educator up here as well. I manage some of the technology and our help with the marketing side of Kopernik too. So there are some other responsibilities I have to focus on, but I am also dedicated to supporting our live stream audience. We built up a nice community here, and I want to make sure that we continue to support you guys and build up this community more and more of night sky observers. Because no matter where you are, this does offer you the opportunity to see things you may not see with your scopes at home, or just at home in general. If you live in a city, it becomes a problem too. So this is a way to deliver the night sky to wherever you are. Okay, so yeah, again, if you want to support us, like the video, subscribe to the channel. There is a donation link in the live chat, a way to donate in the live chat too. But there's also a link in this video's description if you prefer to donate through PayPal. That is an option as well. And all of those donations go right to our nonprofit organization, including if you do it through YouTube, that's through YouTube Giving, so they give us all the proceeds and they cover the transaction costs, which is a nice setup they have going there. Okay, so we got eyes on the supernova. I am happy with that tonight. I don't see too much going on in the chat, so I think we will close out this session of our view of the supernova tonight. We could always return to it as well, depending on how this supernova behaves. It should be visible for a while yet, so if we have a general deep sky observing stream where we bounce around to the Whirlpool Galaxy, we can come back to the Pinwheel, take some new images there, and we'll have fun with that. So yeah, I think it's time we close out this session for tonight. I will be back here in the morning for another program, and also we'll be doing the Friday night program in the evening at 8:30. So we hope to see you there too. Thank you so much for joining us here on the Kopernik Observatory YouTube channel, and as always, look up and dream big, and we'll